we're going to develop one possible model for the ball moving through water. First of all, again, v prime of t equals a equals constant if there's no water. We're assuming a straight ramp and no other influences other than gravity, and we're not going to talk too much about the physics. But okay, so in water we have a function v prime of t equals a, same as it would be if there was no water, but then we have to subtract off some quantity that increases with increasing v, because as v increases we have to move more and more water out of the way every second, and this causes the velocity to build more and more slowly. So one possible model of this type would be v prime of t equals a, the acceleration that the ball would have if there was no water, minus some constant c times v of t. So that we see that the faster the ball moves, the greater this term that we're subtracting from a. Now it turns out that this is an equation that's not particularly difficult to solve, although we're not going to talk yet about how to solve it. Another possible model very similar would be v prime of t equals a minus some constant times the square of the velocity. And it turns out that if you go through the physics of it and test these things and analyze them, there actually are cases when the velocity isn't too great where this kind of model pretty much applies, and others where this model pretty much applies. Now again, either of these models, if we know the value of the constant c, what we have here is a rule that if we put the coordinates of a point v, if we put the v and t coordinates of a point in the v versus t plane into this expression, we're going to get some number that's going to give us the slope, the rate at which the velocity changes. So we're going to get some sort of a slope field here, very similar probably to the ones that we've seen before, where the slope tends to decrease as the velocity increases. If we do the same here, we get a slope field that might be very similar to this one, but of course, since we have the squared velocity, the numbers that we get are going to be a little bit different. Now, neither of these equations is particularly difficult to solve, but we're not going to talk at this point about how to actually go about solving the equation, just trying to illustrate where these sorts of equations can occur. And both of these equations are of the same general form, where again v prime of t is some function of t and v.